Welcome to part 3 of the Module 10 exam review. We're just going to jump in and see what I can do in here. So, if we're going to write this in scientific notation, we need to put the decimal right here between that 1 and the 9. The question is, how many places do we have to move it over? 1, 2, 3, 4, 5, 6. And because we're moving it to the right, we're going to get 1.9418 times 10 to the negative 6th. And that's how we do that. Now, if the number of the statement is written in scientific notation, write it out without exponents. Is written with exponents, use scientific notation. So we want to put this number in scientific notation. A company produces 341,000 small appliances 1 year. To put this in scientific notation, we got to put the decimal between the 3 and the 4. So 3.41 times 10 to the how many decimals we have to move it over? 1, 2, 3, 4, 5. So to the 5th. Now, a computer can do calculations in 1.4 times 10 to the negative 7th seconds. We're going to put this in standard notation, so you have to move the decimal 1, 2, 3, 4, 5, 6, 7 places over, which when we move it 7 places over, that means we have 6 zeros, so 1, 2, 3, 4, 5, 6, 1, 4. That's that. So converting this into decimal notation, moving this over 7, 1, 2, 3, 4. So we moved it 4 to get to the end of the 4, 5, 6, 7, so 3 more to get our 7, so you have 7, 2, 0, 4, 4, and then we need 1, 2, 3 more zeros. We can put some commas in to mark that off if we want. Same thing here, we're going to be moving it to the left, 5, 1, 2, 3, 4, 5, which means we need 4 zeros, 1, 2, 3, 4, 6, 8, 7, 1. Okay, now we're going to multiply or divide and write in scientific notation. So when we're multiplying here, we're going to multiply the numbers. So we need to do 8.25 times 3.40, which is 28.05. So 28.05. Now we multiply the powers of 10. 10 to the negative 3rd times 10 to the 4th. Because we're multiplying like bases, we add the exponents, so this would be times 10 to the 1st. But recall, this is not in scientific notation. 28 isn't because it's not a number between 1 and 10. We move this over, so we get 2.805. As this is getting smaller, this exponent here is getting bigger because it's a 1, and we move that over 1. This would be times 10 to the 2nd. So here dividing 12.06, we want to divide that by 3, so 12.06 divided by 3 is 4.02. When we're dividing this by this, we subtract this off of that, so this is times 10 to the negative 3rd minus negative 6. Negative is a positive, so negative 3 plus 6, 4.02 times 10 to the positive 3rd. That's what we have. Then finally, this last one, this is really a 1 times 10 to the negative 4th, so 2 divided by 1 is 2. Because we're dividing this, we subtract this off of that, so times 10. Or we could just say this is 20. So the next couple, we have a couple story problems here. If the speed of light is 3 times 10 to the 8th meters per second, how long does it take to travel 2.29 times 10 to the 11th meters, the distance from the sun to Mars? So they're giving us a speed, and they're asking us how long does it take to travel a distance. Now, there's a distance, rate, time triangle. Now, because it says how long, we're trying to solve this for time. So time is distance divided by rate. So right here, this is the distance, 2.29 times 10 to the 11th. This is the rate, 3 times 10 to the 8th. So this is now asking us what the question is. So how long is it going to take? So 2.24 divided by 3 is going to be, let's go with 0.74, just round that. And then here, because we have 10 to the 11th divided by 10 to the 8th, this is times 10 to the 3rd power, subtracting the 8 from the 11. And then, I guess if we wanted to do this, we could move this 1, 2, 3, so we could say 704 seconds, and that's just a rounded approximation, so that's good enough for a ballpark measurement. So now this next one says, assume that the volume of the Earth is this cubic meters, and the volume of the bacterium is this cubic meters. If the Earth could be filled with bacteria, how many would it contain? So we're dividing the volume of the Earth by the volume of the bacteria to determine how many bacteria are going to be, determine if the Earth could be filled with bacteria, how many would it contain? So let's see, we have 5 times 10 to the 14th divided by 2.5 times 10 to the negative 16th. Well, 5 divided by 2.5 is 2. Then we subtract this off of that, so times 10 to the 30th. So that's how many bacteria that we could, if we could fill the Earth with bacteria, that's how many it would be. 2 times 10 to the 30th, which that's pretty gross. 2 times 10 to the 30th. We have that. Now, evaluating these polynomials, really we're just plugging numbers in. So here we're going to plug in 2 to that. So you have negative 5 times 2 squared plus 10 times 2 minus 7. So 2 squared is 4 times negative 5 is negative 20. 2 times 10 is 20 minus 7. These cancel, so we get negative 7. Plugging 0 into here. When we plug 0 in for here, that kills that. When we plug 0 in for that, that gets killed. So we really are just going to get 8 there. And then plugging negative 2 into here, we have 4 times, let me do this, 4 times negative 2 cubed plus 3 times negative 2 squared minus negative 2 plus 32. So negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8, times 4 is negative 32. This is 4 times 3 is 12, minus negative 2 is plus 2, then plus 32. Now, minus 32 and plus 32 cancel. 12 and 2 is 14, so we have that there. So finally, these last couple, we're going to combine some like terms, so we're going to collect some like terms here. Now, if we have, that's an 8 to the 9th, 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 oops, excuse me. This is not an 8 to the 9th, that's an 8 to the 5th, that's an 8 to the 5th. So we're combining the 8 to the 9th, we're combining the 8 to the 5th. So we have 8 to the 9th, minus 18, that's negative 7, but then plus 13, that's going to be 6. So we have 6a to the 9th. And then 2a to the 5th minus 6a to the 5th, negative 4a to the 5th. That's what we have there. This next one, combining like terms, we have our x cubes, we have our x to the first, we have our numbers. So if we have 3/7 x to the third plus 1/2, the real question is what is 3/7 plus 1/2? Well, we need to get a common denominator, which is 14, so multiply by 2 over 2, multiply by 7 over 7, so this is going to be 6/14 plus 7/14, which is 13/14, so you have 13/14 x cubed, negative x plus 9 is plus 8x, and then 9 minus 6 is plus 3. So that's that one. And then finally, number 45, we want to combine like terms, so we have 3x to the 8th. So we have 3x to the 8th. There's no other x to the 8th, so that's taken care of. And I'm going to go in descending order. Do we have x to the 7th? Yep, we got 8. So 8x to the 7th, good. Take care of those. Do we have any x to the 6th? Nope. 5th? Nope. 4th? Negative 8 plus 2. Combining those, we get negative 6x to the 4th. So I've taken care of those. I'll cross those off. No x cubes, but we have x squared, so 8x squared. Take care of that. X to the first, yep, negative 8x. And finally, plus 3. So that's that right there. So that's part 3. We'll pick it up with part 4, and going to get done with this.